This is the Kotlin talk, so if that's if what you're here for, you're in the right place. If not, you're welcome to stay. I recommend it. I just a couple of housekeeping bits to get out of the way. You might notice that this is the jankiest of intro slides you've probably ever seen at a talk, and that's because a few days ago my entire laptop just cratered, taking with it all my conference prep, and then my backups failed. So everything you're going to see today was put together, reconstructed in like the last 4 days. It's going to be amazing, I think, but we'll get through it together. The way I like to do talks is I spend most of my time in the IDE anyways, showing code rather than having it on slides. We'll do it in the IDE. What this means for you as attendees is you can ask questions, and I'll actually be able to show you something rather than saying, oh, if only I had a slide. Too bad, so sad. And then, of course, oh, that's probably just a screensaver. Whew. I bumped a cable and the screen went black, and I thought, this cannot get any better than what it's doing now. Anyways, so all that to say is, I'm happy to answer questions along the way. If you have it, just raise your hand. We'll try to get to it. I don't have well, I obviously have a set agenda, but I'm mostly here to make sure that all of you get something out of this that makes it worth coming for. So if you have questions, ask, and I'll try to answer. If not, I can point this somewhere we might get the answers. So with that out of the way, my name is Justin. I work at Red Hat. I work on the Quarkus team, and we'll see like a very brief demo of Quarkus later. Not because we're here for Quarkus, but on the Quarkus team, I'm one of the people, the primary guy, but one of several, who work on the Kotlin support inside Quarkus. So anyone heard Quarkus? Yeah, okay. If you want to try the two together, then you're going to be using the stuff that I've done to make it work. So that's why we'll see that demo from other things. Yeah, so it's a little bit about me. I've been doing Kotlin for a long, long time now, and it is, I'm a little bit known with my friends for being a little exuberant about Kotlin, and a friend of mine made this video for me to kind of explain how I feel about Kotlin. And it's going to go, oh, let me get out of, this is not my normal laptop either, so it's all a little squidgy. So a friend of mine made this video to share how he views my advocacy of Kotlin. This is a video from years back called The Most Inefficient Murder in History. And that is what I believe to be the Grim Reaper chasing a man, bludgeoning him slowly with a spoon. So yeah, so that's what it feels like as a fan of a new language when everyone else is like, we just want to do Java. But do you know about Kotlin? Anyways, he asked me not to name him, but he is here at the conference. So, anyhow, so that's Kotlin. So, how many of you have used Kotlin before? Okay, how many of you have never even heard of it before today? Hopefully not. It's around, right? So, one of my big frustrations with Kotlin is, so when I first started Kotlin, I saw it at a small side room at Java 1 years ago, and Hadi Hariri was giving his presentations, Kotlin, and I'm like, yeah, this is awesome. And it was great, so I started using it. And then Google decided to make it a supported language and then a preferred language for Android. And since, anytime Kotlin gets mentioned, they're like, oh, you're an Android developer. I'm like, no, I'm a back-end developer. I work on REST services and database drivers and stuff. I've actually never written a single Android app in my life. I've opened the editor a few times and kind of like got bleary-eyed and switched off. So what I want to do with this talk is show that Kotlin is amazing, but it's not an Android language. You can do some fun stuff with it. So what we're going to start off, for those who have not seen the language, or maybe not seen it a whole lot, we're going to do like a language tour to show some of the features that make it kind of interesting. And then we'll do a handful of quick demos to see like different scenarios where you might use Kotlin that have nothing to do with building a mobile app. Mobile apps are great and whatever, but that's just not, it's not what I do. So we're going to start the tour with, no, Where, oh my God. Where's my source code? This week could not get any worse for me. Oh, no, that's right. I used to do, I do code-based stuff, and I used to do it all in here, and it got like really hard to like do demos, and then I thought, I can actually do it as a unit test, and we can run it and see it happen. So it's not in main, it's in test. My heart can stop pounding now. Anyways, so a basic class in Kotlin will look almost exactly like Java. One of the changes that the Kotlin designers made was in terms of the visibility modifiers. When they were designing the language and making choices about what was what, they did an audit of all these projects on GitHub. And the most common modifier used was public, right? Public class, public static void main, public get, whatever. And one of their goals was to reduce the boilerplate necessary to write code. And if you're always going to slap public on a function or a class or whatever, why not make that the default and reduce the amount of code that you see? So this is actually a public class, and coming from the Java world, you're like, but that's the package private, whatever. No, it's public. If you were to, you can add modifiers, you can make them protected like you would anywhere else. Did I spell that wrong? Oh, no, because it's, in this context, protected doesn't work. But you can do private. There's an internal modifier, which has to do with kind of how Kotlin manages. It's sort of like package private and sort of like modules, but the word module is like terribly overloaded, so no one likes to use that particular word. But it has something to do with that basic concept. I don't know that internal translates well outside of Kotlin. One of the goals of the Kotlin development was to make it interoperable. So you can both consume Java libraries, you can also be consumed by Java libraries. So has anyone written Scala code or used Scala libraries? Like I've tried using Scala libraries from Java, and there's always like weird things as part of the method signatures. Sometimes it shows up because Scala does some amazing things, and it's hard to hide that from the bytecode, and it feels weird to use Scala code from Java sometimes. Kotlin tried to avoid that. Some of the choices that were made you'll see kind of play into that. But for the most part, it's pretty straightforward. Now, so classes should look familiar. Now in Java, we have fields on classes. So you have public, private, whatever, some field. Then you have to write your getter and your setter, depending if it's mutable or whatever. Kotlin actually has properties. So when you define a property in Kotlin, it will look like this. Now, what Kotlin does is it inverts it a little bit, so you can have var or val. And if you've done Java 10, like we all now have var in local variables at least. So in Kotlin, you have var and val, and it's roughly the same. If you've done Scala, it's exactly the same. Var is mutable, val is not. But what you get here for free is, in the bytecode at least, if it's a var, you'll get a get method and you'll get a set method for free. So if you were to use it from Java, you would actually call get name or set name or whatever. But in Kotlin, you can actually just refer to the property directly. So you'd say foo.name equals, and it looks like it's field access, but it's really not if you look at the bytecode. But again, that reduces the boilerplate necessary to interact with the class, right? Now, you'll notice the red squigglies. And here's one of the biggest differences you've probably heard about, and if not, I'll explain it. Kotlin builds into the type system nullability in Java, as most of us have done Java, right? Probably all of us if you're here, right? Our code is just littered, if blah not equal to null, blah, 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 blah. Well, Kotlin builds that nullability into the type system so that whenever you're interacting with a property, a local variable, whatever, you can actually tell at the compiler's syntax level whether something can be null or not. And then if it can't be null, there's no reason to ever check for null because it can't. It won't compile if you try to assign it. And how it does that is this little modifier there. It's the question mark. So it makes the difference between string and string. I don't know how else to describe it. But this means that the property name can be null. Now it's still red, squiggly, you'll notice, because we have to actually assign it to something. and now the red squiggly goes away. So you have to give it some sort of value, whether it's, well, especially if it's not nullable, obviously you have to give it a value, otherwise it'd end up being null. So you have to initialize it. And the same with the int. We have to give it a value. Now, int is interesting because it's an object. Everything in Kotlin is an object. And you might be thinking, that's terribly inefficient to always have objects for your numbers. And you'd be right. But they did something very clever. How many of you are familiar with bytecode, if this will work? How many of you can read bytecode? Yeah, exactly. You're not expected to. Up until about 3 years ago, 4 years ago, I was like, I don't know either. But my job on Quarkus has fixed that for me. So if this will compile, because we did a bunch of bytecode generation, so I had to learn to read stuff. This may not, if it comes up, I'll show you. If not, I'll just explain it. The difference between int and int is what it gets generated as. So in the bytecode, if you see int, it actually compiles down to the primitive. So at the bytecode level, it's a primitive, and you just pass things around, and it's super efficient. If you put the question mark on it, which means it can now be nullable, it actually compiles down to an integer. So those are actual objects, right? But at the source code level, it all just looks like an int, and you can treat it as an object. There are functions attached to the int type that you can do things with. Whereas with the Java, of course, you have to, if it's an int, you have to pass everything off into integer and static functions and stuff. But Kotlin makes a distinction at the source, at the language level, that makes it a lot more seamless. You just treat everything as an object because as far as you're concerned, at the source, everything is an object, and then the compiler does fancy things. I'm a little sad. It doesn't matter. It's not like anyone here can read bytecode, but it's fun to look at sometimes. We'll close that. So that's nullability, and it's actually quite amazing. I had a project that I've been abusing for years. It was my playground for trying things. And I converted it to Kotlin. There's actually a function in IntelliJ. You can take source code and it will convert it from Java to Kotlin for you. So if you want to see what would my project look like as Kotlin, you can actually do the entire tree. It'll convert all your source code to Kotlin. Make sure you've committed beforehand so you can revert easily, because you might look at it and think, ugh, that's ugh. Anyways. But I converted it all to Kotlin, and then just with nullability, I found all these places where I wasn't doing proper checking. All these bugs that I just got lucky to have never run into because I wasn't doing proper null checks. And the nullability found all those for me. And that was just by converting the code. I found a whole bunch of bugs. So it's actually, it's great. And one of the nice things about it is, if it'll let me do this, let's do this. So we have name. It can be nullable, so we have to be careful. So we do that. It's not the Elvis operator, that's something else. I don't know what this operator is called. But it basically, it says if name is not null, then let's, the what? The safety reference operator, something like that. So what this does is, it says if name is not null, then call the length function on it. Do I have to put the parentheses on it? I forget. I never call that function. No, I'll get to that. So if it's not null, call me the length on it. Otherwise, you can do this and give it a function. That's the Elvis operator. Exactly, little curl. So this is a nice, safe way to say, if it's not null, give me the length of it, even though I think I don't need those. Yeah. There's a Kotlin.string, which is slightly different than the Java lang string, so it can be confusing. But this is a safe way to say, if it's not null, give me the length of it. If it is null, we'll just say it's 0, or more appropriately, probably, because you can't have a negative length of a string. So now you know that name was null and age, which makes no sense there. Anyways, that's how you can safely dereference these nullable types inside your code. And it's super nice. It's super succinct. If you've ever changed method calls, and at each step you have I have to make a variable and check if it's null, and then I can call the next one. This makes Fluent APIs much, much nicer, especially when you're doing streaming operations and mapping elements in a collection, for example. So that's basic property stuff. The next thing that makes Java a little bit more interesting is you can actually have lazy initialization. So if you have an entity type, my phone just buzzed. Let me put it on Do Not Disturb. I forgot. if you have a property on a type that's maybe it goes out to the network and downloads something, or maybe it loads a PDF into memory. You don't want to do that every time you instantiate the object because that's a very expensive operation, whatever it might happen to be. So you can lazy init things. So in this case, what we're doing is we're declaring a string, a lazy string, and we're going to initialize it using the by lazy. And there's a number of different, these are called delegates. There's a number of different delegates you can use, but this one is a lazy initialization. And so what happens is what's inside that little lambda does not happen until you dereference the string. And if we come down, I should have a test in here somewhere, but apparently I don't. So if you come down here, you're going to preview it, functions. That's a function. It's called functions in Kotlin and not methods for reasons. So we're going to say, right, val lazy. So let's do this. We're going to print hi. And then we're going to say print line. We're going to create example. Oh, no, yeah, we should actually, let's do this. Example, we're going to print hi again, and then we're going to print lazy. Now, if we run this, and hopefully the fonts work out. The ASM thing finally woke up. Starting the demo. You see we got the two highs, there's the delay, and then we got lazy. You see that gap in there, how quickly it went? It's because we're forcing a little bit of delay in that. So lazy was not evaluated until we actually called it. And that's lazy initialization. There's a number of delegates you can do. There's some non-nullability things to enforce that the value you get back is non-null. I haven't seen those used as much, but they're there. Okay, so let's go over a little bit what we did here. So you'll notice here I created, this is how you instantiate in Kotlin. You'll notice there's no new keyword. Again, it was boilerplate that seemed unnecessary, so they cut it. So you don't have to call new whenever you call a constructor. Because why? But, so what do constructors look like? So in Kotlin, this actually has a standard nowhere constructor like you'd have in Java. It's implicitly done, it's just there, right? Now what you could do, if you were so inclined, and this will look familiar to the Scala types among us, you can actually declare all of your properties, your class properties, as part of the constructor. You know what the difference between this is now I can't create an example without passing in a value for name, right? Because it's the one property that we have to have in order to create a class. And if we come down here, you'll see there's the red squiggly because we're not passing in a value. So you can do all of your properties as constructor parameters like that if you like, if that makes sense for your particular type, or you can declare them in the body depending on how you want to do it. If you're working with persistence frameworks like Hibernate, I have one called Morphia, or if you're doing some Jackson stuff, sometimes they have opinions about whether or not you have like a nowhere constructor or not, so you might have to choose depending on what that particular framework needs. But I think most of them now can work around having actual constructors. So that's what that looks like. And if you wanted a secondary constructor, there's a keyword called constructor, and then you can give it whatever, you can add parameters, and then you would say this, and that's how you call the other constructor. Because you have to call like the primary constructor at some point. And this is a secondary constructor. So that's constructors. We'll talk about functions real quick before extensions. So if you were to define a function on example, which we did here actually, they look just like methods. Function upper, if you wanted to return the uppercase, you could return name dot uppercase. Right. So red squigglies, what's going on there? It's because I'm trying to return a value, but I didn't say that my function returned something. The default in, oops, I went up one line. The default in Kotlin is to have what's called a unit function. So unit is roughly equivalent to void. In Java, of course, you have to say something. So we would say, public void upper. Did I put 3 P's in upper? I did. So you have to declare that return type, whatever it is. Even if it's void, you have to say void and give it the function name, the method name. In Kotlin, you can leave it off, and it just assumes that it's a unit function, right? So if you were to be explicit about it, you could do that, and that's what, without a type, that's what it looks like functionally speaking. But we want to return a string, so we do that. Now red squigglies are gone. So just like with the properties, it's always the symbol name, colon, and then the type. And everywhere in Kotlin, it's going to look like that. And we'll see the same with extensions here in a bit. But this is what a function looks like. You can do some fancy things. And again, because Kotlin is all about reducing the boilerplate necessary to write code, you can actually do something very cool here. You can convert this to an expression body, right? So here's a function that takes 3 lines to really just return a value. So you could do that. And that's called a function expression. It's really nice if you have a bunch of just really simple methods. Now suddenly, instead of having code, you can have code. And it's super nice. It can be overdone, of course. I've gone crazy and had to roll it back. And actually, I wouldn't mind a little bit more white space around the code I'm trying to read, because if you have a whole bunch of them, it can get really dense. But it can be handy on cases when you have kind of one-liners, which we'll see. So before we get to this other stuff, so one of the nice things that Kotlin offers are extension functions. We've all written static helper methods, right, to do something. Give the SHA-256 of a string, you have to write a function, you pass it in or whatever. With Kotlin, you can actually do extension functions. So you can actually, it looks like this. So fun is the keyword. You give it the receiver type, so in this case, string. We're going to add a function to string, and then we'll call it, I don't know, hex, whatever it's going to be. And it's going to return another string. Now, I'm not going to write it because it would take a while. But for example, if we wanted to say for every character in this string, replace the character with its ASCII hex value and then give me that long string. It's a nonsense method, of course, but you could do that here. And then anywhere you needed to, let's just get rid of the squiggles. We're going to return an empty string. And then you could do this. And now it looks like it exists on that type. You don't have to own it. You can do it to JDK types. You can do it to Kotlin standard lib types. You can do it to Hibernate. Whatever your library is, you can attach this. Now what this looks like in the bytecode is actually is a static function that exists somewhere, and the compiler will call your function and return the type and everything. But at the source level, then this suddenly becomes very, very fluent. Instead of having to break out with a local variable to call this and then get back into your flow, you write an extension function. You can just do it all in line. And it makes for some very nice code, especially once you start writing DSL, which we'll get to briefly. It fixes a lot of problems. Now, let's talk extension briefly so we can talk about overloading. So if we were to extend a type, all right, I'm going to throw a couple of concepts at you, but then we'll get to some demos. So let's say that you wanted to extend map. And map takes 2 parameters, right? Key and value. Now it's going to complain because we don't have key and value, so let's add our own generic types, K and B. Now everything's happy. Now it's not happy here because you can see the red squiggles. And you can guess the problem, right? I implemented an interface and it didn't implement any of the functions. And if you've looked at the map interface, you'll know that there's 8,000 methods on it. And implementing them all is just horrendous. So one of my favorite features that I've not seen anywhere else, let's get rid of you, is, remember how I mentioned there were various delegates that you could do? You can actually do delegation with extension. So what we're going to do is we're going to say we're going to take in val map. And it's going to be, for reasons we'll get to in a second, it's going to be a mutable map of KV. So Kotlin makes a distinction between mutable and immutable types. the list type is immutable, so you can read from it, but you can add to it. But there's a mutable list. So there's a map and a mutable map and a set and a mutable set. Because Kotlin tries to favor immutability over mutability by default, but it makes it very easy to say, no, I really do need to mutate my data. So in this case, we're going to extend mutable map like so. Now we still have the red squiggle, right? But we can do this. And this is extension by delegation. You saw the red squiggle go away? Now what happens is if I call put on example, I didn't write a put method, but there is a put method on mutable map. So the compiler knows call map.put inside of example. So all the stuff that map gives us, then we delegated to with this particular variable. And this is amazing. So you should never probably extend map or list or whatever directly, but it's kind of fun for demos. But for whatever your type is, if you want to wrap a certain heuristic around the use of that particular type, you just wrap it in this particular type. You can actually pass this around as a map wherever you go, and it'll think it's a map, but it's really running your code. So I had a demo once where I made like a histogram of the size of the list over time. So I added like a function and it printed out a little bar chart. I don't have it here because there are other things to look at. But this makes extending and wrapping those types very simple because you don't have to re-implement the world just to add whatever that heuristic is, security checks or whatever, and it's all there. And the nice thing about this is because we're passing in the implementation that we want to use, you can actually change that on the fly. Sometimes maybe you want it in sorted order, so you'd pass in a tree map. Or sometimes you want it in insertion order. When you iterate, you just pass in a linked hash map. And it doesn't matter because you created it and you passed in the delegate to use, and then you just use your type however you want to do it, and then you can iterate it however you want. And if you want to change up the iteration order, you just change what type you pass in at the beginning. And it makes it all that transparent. You don't have to go back and rewrite or write two different versions of the same type and implement common interfaces. It just does it for you. I love this feature, and I wish it was more popular with people, and I wish other languages had it because it's so handy sometimes. But all that to say is let's look at overloads. So one of the functions on a map is a put, and it's going to say, I'm going to get this wrong. Let me see. Again, this is not the laptop I normally use, so the keyboard is going to freak out on me. Let's override a method. We're going to override, not compute, put. Here we go. Oops. Enter. So with an override, it looks just like it would in Java. In Java, we have the optional annotation at override, and that's just a hint to the compiler to say, if I happen to mangle this API, this function signature, I want you to complain for me because I intend for this to override a function, a method in the parent type, right? Now I can leave off at override, and Java will just happily compile that method because it's just a method. It doesn't know, right? So in Kotlin, you're actually required to add the keyword, not an annotation, the keyword override. And if I take that off, it will actually complain because I'm now hiding a method in the parent type. So I either need to tell it that I want to override it, or I need to rename this to avoid any sort of ambiguity in the function resolution. And then, yeah, so the map returns back whatever the prior value might have been. So in this case, it returns back the nullable v, because maybe it's an empty map and there's nothing to return, so it would just return null. So this is, while it's here and while we're looking at it, this is a function called to-do, and it's the default template whenever you override a function. And this will actually throw an exception because I haven't implemented it, right? And it's a nice way to put in like little slabs to remind yourself like, oh, I didn't implement this, rather than like just silently working. It'll literally crash your application because you forgot to do this code. The return type for this is nothing. So in Kotlin, everything extends any. So any sits above object, essentially. And that works with the nullable and the non-nullable, like int types, everything's an any. On the other end of the story, nothing extends everything. So if you're going to write a function that will never return a value, like this one, you can say it returns nothing. So I can't assign the return value of this function to anything, because nothing isn't a valid property type. But it's useful for declaring, to making sure that you don't use it that way. And in this case, it's actually going to throw an exception every time I call it, so there is no return value because we're literally going to throw the stack away and find the next error handler. So it returns nothing. Anyways, little side story. All right, functions, extensions, overloads. Okay, one more feature, and then we'll move on to some demos. One of my favorite things about Kotlin is default and named parameters. How many of you know what those are? Yeah? They're common enough that most of us have probably seen them here or there. So let's say we have a function that does something. And it takes some parameters. We're going to take num, that's an int, and, oh, not val, value, I guess. The trackpad, my thumb keeps hitting it. Value, that's a string. Whatever those might happen to do, whatever. Now sometimes you have like optional parameters to a method, right? So what do you do in Java? You write like 4 different versions of your function that have certain parameters and leave off others, and then you like call the longer methods with the default value, then you have like 6 methods to do the one thing that you really wanted to do, but you're trying to be flexible. So Kotlin fixes that, as you can actually say that default value is 0, and this default value is an empty string. So now I can call foo with no parameters, and it just works. Whenever you call it, the compiler will insert 0 in the empty string. Or if I wanted to, let's do some infinite recursion here, huh? So if I wanted to call it, I can actually do, I'm going to pass it a string, and I'm going to pass in hi. Now you notice the red squiggly, right? Because hi, string, is not an int. That's the first parameter in the list, right? So how do you get to the string? You just come in here and you say value. There we go. You just name your parameter. And then when the compiler compiles, it says, oh, I know what that parameter is. And then it'll inject the 0, and put your thing in the code, and then it just works. So this lets you have a dozen different optional parameters on your function when you only really want to maybe use 3 or 4 actively on a regular basis, and then default the rest. And then you get the one function. And when you're looking at your, well, it's not JavaDoc, but when you're looking at your documentation, you just have the one thing to look at, one set of documentation to maintain and to read, and it's just there. Now, in terms of Java operability, that's not so great. Let me finish this thought, and then I'll answer you. In the Java world, you will see you'll see the one function, and it takes all 12 parameters. So if you're coming at it from Java, it's not so friendly, because you still have to enter in all those parameters. There is an annotation, and again, this is a whole other talk, but there is an annotation where you can tell it this, and when the compiler generates the bytecode, it'll generate one function with all 12 parameters, and then it'll generate another one. It'll take the last defaulted parameter, just drop it, and it'll generate a function that just takes that, and then it'll do the one for you where it adds the default parameter, calls the bigger one. And it'll just keep pulling off default parameters off the end of it until you have maybe 13 functions as it strips off each default. So on the Java side, you'd still have like, way too many functions to look at, but it makes it nicer to use from Java than have to remember like, oh, I have to put in all these parameters every time. So there's a few kind of safety hatches that Kotlin uses to make it nicer for Java people that you don't have to worry about if you're just writing in pure Kotlin. So yes. Yeah, if you look at the documentation, Kotlin uses a tool called Dokka, D-O-K-K-A, if you want to go look it up later. So it looks like JavaDoc, or it operates like JavaDoc. It actually looks very different from JavaDoc. But it would be in that generated documentation. You'd see that each parameter has a defaulted value, and it would be part of the documentation. Oops, don't touch the microphones. I think that is... Okay, that's it for the language features. I don't want to belabor the point because we have a little bit of time left. Okay, so I'm going to do just a couple of quick demos to kind of give you a taste of like where you might use Kotlin That's not an Android app. But before we get to that, I'm going to show you the one thing. How many of you have heard of Project Loom coming up, right? It'll revolutionize how Java does multi-threading and everything. Very excited about it. But we don't know when it's going to actually arrive. Maybe Java 19, maybe 20, maybe Java 24. It'll arrive when it's ready, is the answer, right? But you might not want to wait that long. Kotlin has a thing called coroutines, and this is literally a whole other talk. But it's highly scalable. It's built in. There's an actor system, if you're familiar with the actor model, akka, kind of all those things. It's part of Kotlin's offering. It's a separate module that you'd import via Maven or whatever, but it's developed by the Kotlin team in lockstep with things. So let's do a quick test. I don't want to do 1 million, just to show you how well it works. Let's start with 10,000. So if we're going to do 10,000 threads, we're going to run it, and hopefully you can see this. Go away. It's still going to complain. All my demo code. All right, let's try that again. Oh, why are you still complaining? Oh. All right, no more red lines. So it's going to compile. So what we're doing now is we're doing 10,000 jobs in an executor. And all it's doing is just incrementing an atomic integer. There's nothing fancy going on here. But you can see it's queuing threads. Or trying to. This might be slower than I remembered. It's taken a while, is the point, right? So let's stop this, because we don't want to sit here and watch this. This is dumb. Stop. So that's using threads. Let's do the exact same thing with coroutines. So this is what it looks like briefly. There's our atomic integer that we're going to increment. We're going to do, this is a handy little method. This creates a list of size count, and you can pass it in basically a supplier. Say for each item in the list, up from 0 to count, run this closure and assign the return value out of it to that particular position in the list. A little shorthand syntax. So all it's doing in this is we're using a keyword called launch, which launches a coroutine on the global scope, and that's a whole lot of stuff that you don't have to remember because coroutines are talking amongst themselves. But it launches basically a coroutine off onto the pool, and all it does is there's a delay, so we're going to wait 1 second, and that's part of what was taking so long with the other one. Is built into this is we're going to wait a second, and then we're going to increment the number, then we're going to return it. And you would think even with 10,000, that's going to take a while, right? But we're going to do it in parallel. So remember how long it was taking? Yeah. That finished before I could even finish the sentence, right? The thread pool was, even though you're using an executor service and submitting jobs, it was taking forever just to boot up. That one started, finished, and returned before I could even finish half a sentence. And that's coroutines. And if you want to see just how obscene that is, if we go back up to, what is that number? That looks like, okay, 1 million. I want to make sure I'm not launching a billion things going on. So we're gonna up the ante, and we're gonna do 1 million concurrent jobs on this not great laptop. Run. There we go. It took 602 milliseconds to go do its thing and come back. And I got all 1 million of them done. That's coroutines at its very basic level. There's a lot here that you can do, and I don't want to go into it because I want to show some other things. But this is a really compelling, for me, it's a really compelling thing that Loom is going to be amazing, I think, when it lands. I think it'll change the world for us as Java developers. But it's, 5 years off, potentially. Even if it comes in Java 19, if your company's like most and only uses LTSs, the latest LTS is 17. People are still migrating to 11. The next LTS will be, 23 in a few years' time. Give that another 5 years for enterprises to migrate to 23. You could be waiting a long time for Loom. You can have this today if you really need it. In the meantime, when Loom comes along, I have every expectation that probably coroutines will be reworked to work on top of Loom. It'll only help make coroutines better. So you won't lose an investment by writing all these coroutines and then having to rewrite it for Loom. You, in theory, should get all those new benefits for free because Loom will be like a fundamental piece of the stack that then coroutines can take advantage of. So, okay, those are the Kotlin language examples. So before we get to the first one, I want to talk about streaming, in part because the way the syntax works. So we've all done like mapping with collection list, right? You do .stream, map, flat map, blah, 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 blah. So Kotlin has its own API, and it looks very, very similar. In this simple example, we are taking the names of all of our favorite characters from The Good Place. Any fans of The Good Place? One of my favorite shows. It's so good. We're going to take a list of names, and we're going to run them to lowercase. And if we run it, you can see how amazingly powerful it is that it can lowercase a list of strings in just a handful of seconds. Where is my... It's in there somewhere. There it is. You can see there's our results. Yay, it's magic. Super powerful stuff. But what I wanted to mention here, because it'll matter here in a second, you see these the parentheses, it takes in a lambda, like this is what our map function is, we're passing in a lambda. What Kotlin does, again, to reduce boilerplate in general, and it helps in specific later, you can actually remove, oh, that's why, there's the mouse. You can actually move the lambda out of parentheses. When you have a function and the very last parameter is a lambda, you can actually, when you're calling that function, you can move that lambda outside of the parentheses. And it looks weird, but it can look weird. But in this case, it looks rather clean, right? Nice and succinct. And where this really matters, and we'll see it here in a second, is when you're writing a DSL in Kotlin, you don't have to worry about like parentheses and braces everywhere, and suddenly that becomes just a lot of code to have to sift through. You can actually move it out of your parentheses, and it makes it look a really nice DSL, which we're going to look at right now. So, one of the ways that you can use Kotlin without writing an app is in a different module. No! There's a project called Ktor. Who here writes microservices? Yeah? There's like 1,000 different libraries to write your microservices. I happen to work on one of them. Lots of choices these days, which is great. But Ktor is a pure Java, a pure Kotlin, I'm sorry, framework for writing microservices. So you can leverage like every single thing you want out of the Kotlin language and build your microservice, and it's amazing. So in this simple example, let me get rid of all the other bits. This is what it looks like, and I know it's super exciting, but let's take a look at the configure the routing. So here we actually have a DSL defined. Anyone ever used like vertex routes, or there's one called Ninja? There's a few. I think Spring Boot has a very similar syntax. So this DSL defines like what all your endpoints are. So in this case, we have one, a root, whatever. We have something up, an endpoint to return a static asset of some sort, and then this is a separate thing to install error handlers for your 404s, your 500s, kind of whatever. You can define like what happens when you get an exception. Here's the page you show, and it's a very simple DSL to get that done. And then what that looks like, if we can find the start point. There's a it's an application KT. So in the main, you can run it. It's building. So while it's doing that, and we'll take a look at it in a second, there's also templating, and this is where the DSL comes in. There's actually a built-in HTML DSL if you like building HTML pages in code. I know people that enjoy it. It's not my bag. It gets complicated very quickly. You can actually build your, an HTML page however complicated you want it to be in Kotlin DSL. So, here we're defining what our body is. How do we know what to make the body? Well, here's a lambda. could not delete file permissions. We pass in a function. It's like, this is how you build a body. And the first thing in the body is we have an h1 tag. And what's the h1 tag? We're going to say it's an HTML. This is a weird syntax, and it's in part with how the function resolution does. So this is actually an overloaded operator. Say here, add this string to the h1 tag. It's the one like weird part of this particular DSL. I get why it's there. It just looks kind of weird, but it's harmless. But then if you want, you can write all your Kotlin code. You can pull from a database. You can iterate over, order items or whatever and build your HTML page and send it back. You can do it all in pure Kotlin. I would show you how it's running, but apparently there's a file lock somewhere in Windows is finicky about such things, and we're running out of time. So that's a DSL in Kotlin. Kotlin also has its own serialization library, which is handy. One of the things that might appeal to you in terms of writing a Kotlin application is that there's a thing called Kotlin multi-platform, which I know James is a big fan of. So if you do happen to have mobile applications and you have Android and you have iOS and you have like the website version of it, one of the problems is sharing code across those, right? So with Kotlin multi-platform, you can actually write all your business logic in Kotlin, share those objects between all 3 platforms, and there's actually also a desktop option, so all 4 platforms. Share all your business common code in one module, and then for each particular platform, for your Android or iOS, you have that particular code to build that particular UI, and again, you can write all that in Kotlin, and then when you compile down, it'll build, like your Android image, it'll build your iOS image, it'll build your desktop application, your web application, whatever those particular modules, artifacts are, it'll build all those, and you can share the same code across all of those. You put all your common business logic, themes, all that sort of stuff, you can store it in common place. And you don't have to then, like, here's your Java application, here's your Swift application over here, and then over here's your Android stuff. It's all in one place, and it's fantastic. So to make that happen, there's a number of libraries, but in this case, there's a serialization library that works across all those different platforms. So you have one set of code. You're not using Jackson in one place and then whatever Swift uses to serialize entities back and forth. You just have one set of code that you have to know and understand. It all feels like writing Kotlin code, and that's Kotlin serialization. And it works just like you would expect if you're familiar with it. Probably everyone here has used Jackson. Yeah, it feels exactly the same. You'll see the JSON, and it's there. There's some configuration to do, but that's Ktor, and it's the all-in method. Like if you really like Kotlin, you just really want to write Kotlin everywhere, Ktor is like the hardcore version of that. However, most of us have spent the last few years using, REST Easy and Hibernate and kind of all these kind of Java EE, Jakarta EE libraries. So if that is where you are, and that's where probably most of us are, there are a couple of options there. Now, I will say, I'm going to show you Quarkus because I work on Quarkus and I know Quarkus, and this is not here as a pitch for Quarkus, although you should. If you're a Spring shop, Spring has great support for Kotlin, and I don't mean to denigrate them at all. They're doing a really great job supporting Kotlin as well. So if you're already a Spring shop, you can use Kotlin there with hardly a problem. And what that looks like is it looks like every other endpoint you've ever written. It looks rather bland. Like if you're used to writing REST, like REST Easy or whatever, they're not fancy. Nothing to get terribly excited about. But you could write them in Kotlin if you wanted, and everything just works. And this is what I spend my days making work. One thing to note in Kotlin is if you have like an injected thing, you don't want it to be nullable because you're going to inject it, right? And you don't want to have to deal with null everywhere. Whereas if you just did your normal add inject in the field, it's going to complain because you're not giving it a value, but you're going to anyways. The shortcut or the fix for that is this thing called late init. And this is a keyword. It just tells the compiler, I know I'm saying this is not nullable, and I know I'm not giving it a value. And I know that you hate that, but trust me, something is going to come along behind and give it a value before I use it. And that's what late init does, is it tells the compiler, like, just chill for a second, we're going to get to you. And then once the injection happens, of course, it's now no longer null, and you can just treat it like you would any other null resource. So that's what late init means. And if you start doing this sort of work and you don't know about late init, it can be very frustrating to have to label everything as null. But then all the rest just looks like if you've written a REST easy thing, this is what it looks like. At produces, at consumes, media type, all that sort of stuff. It just works. So if you're familiar with all those libraries, you just keep using the same stuff that you've always used. You just change the syntax you use. And Quarkus is great for that. One final, is there another one? I was going to show one other thing, but I think it's busted. There is a thing, I'll show it to you, and I'll just give a caveat. So there's a thing called Jbang. So if you really want to write CLI applications for whatever reason, I actually write a lot of scripts. I have some scripts written in Kotlin. Quarkus has a CLI module that you could use. It's a little bit of work to get that going because it's a whole build process, whatever. But there's a thing called Jbang. How many of you have heard of Jbang? Yeah, the other red hatter in the room. Jbang is amazing. You should go, it's like jbang.org. But it lets you write your scripts in Java or Kotlin, because I wanted to write it in Kotlin. And then you just run it like a script. So it looks like a bash script or Perl or whatever is your scripting language of choice. You can write it in Java. You can write it in Kotlin. And it will actually download a JDK for you. If you say this particular script really needs Java 15 for whatever reason, it'll actually go download it for you and run it. So you can like send the script to your friend who has Jbang installed, and it just works. So whatever dependencies you need, you can list it. I don't think I have any deps. You would do dependencies in there, and then it's just like your normal Maven, group artifact version. You just list it in there, and then you can run your script just like you would a bash script. This would work, except it's slightly broken in the runtime because it's missing a class path issue for some reason. So I have to go look at that. But if you want to write it in Java, then it all just kind of works. And you can write your scripts in Kotlin. I have a whole suite of scripts that I use to help develop Quarkus to minimize, because I have to rebuild this and do that, whatever. And they're all written in Kotlin. And they just run on the command line, and I run like any other script. And it's amazing. So anyways, those are very brief. I know it was a little bit of a whirlwind there towards the end. So there's a couple of ideas. There's actually, I mentioned a desktop. There's a thing called Desktop Compose that is sort of related to Jetpack Compose if you're a mobile developer, but it's targeting desktops. So you can write your desktops in Kotlin rather than using JavaFX. I don't know what it uses behind the scenes, but you can write your applications in Kotlin. Yes? That I don't know. The question was about unifying between the Jetpack Compose and the desktop. I haven't done a whole lot with it. I've dabbled with it. Desktop Compose is kind of the evolution of Jetpack Compose onto the desktop, and so there's a little bit of disconnect between those two environments. But I've seen some demo apps that are just absolutely stunning, and again, all written in Kotlin as well. Okay, so I think that's the last demo that I have set up. Are there any questions that I can answer? You want to go back to certain syntaxes? Okay. Okay, so there's a couple questions. Basically, like when you're debugging, like what do you see in terms of like thread pools and this and that, and then what does a bytecode look like? The easy answer is what do you see in the debugger? IDEA actually has some really advanced tooling specifically around coroutines. There's a lot that's kind of going on, but you can just you set a breakpoint, and it'll work just like any other breakpoint. If you look at the stack and you look at some of the variables in place, you'll see a lot of kind of the coroutine internals. But you can debug it like you would any other function, and the fact that it's being run in parallel and asynchronously and everything isn't necessarily an issue. You can set a breakpoint, it'll stop, and you just debug as usual. It's called structured concurrency, so it's designed to look like you just do normal kind of iterative code. If you've ever tried to like debug something off on an executor service, it gets weird about trying to set a breakpoint for this particular thread for that value or whatever. Coroutines are pretty straightforward to work with and debug. And as for what the bytecode looks like, that's actually a very complicated answer. because what happens internally when you run a bytecode, there's a keyword called suspend, and that tells the compiler that this is a suspend point, because the way that coroutines work so well is rather than having a chunk of code executing on a thread until it's done, what happens is you have threads running, and then they'll grab a coroutine, they'll do a little bit of work, and when it gets to a suspend point, it'll put it back, and they'll grab another one and do a little bit of work. So rather than having to like context switch on and off threads, you just have that thread just keep running on and on and on, and it just changes which chunk of code it's working. So where that gets tricky is like you get to the suspend point and you put it back on the shelf. When you come back to it, you have to know like, well, where was I? I can't start at the beginning. That's silly. I've already done all this work. So in the bytecode, there's actually a giant switch expression basically in the bytecode. And it sets a flag internally saying, I got to this particular point. So when you come back, go to this next point and execute the code. It's actually very, very clever, and it's very, very well done. But if you look at a lot of bytecode and suddenly you look at the coroutine bytecode, there's just like an explosion. There's a couple of like generated classes that are involved, some bridge methods. It gets complicated if you don't know what's going on. But essentially what's going on, it builds a little state machine at the call site to help manage, you know, how it resumes from a suspend point once it comes back. Does that make sense? Okay. Anything else? Yes. Okay. Uh-huh. If you have a function that returns nothing, well, you're basically saying, have you ever written in Java, you're writing code and you say throws new null pointer exception, and then you write code after it, and your IDE complains. Like this is an unreachable point in code and the compiler just won't compile it. If you have a function that returns nothing, everything beyond that is unreachable. Because what the nothing return type tells the compiler is like, this function will never return. Not that it returns nothing, because that's unit, right? If you're not going to return anything, you just return unit and keep on about it. But the nothing keyword says that this function will never return normally. Because usually those are used for like the error handlers to throw an exception. And then when you hit the exception, you start unrolling the stack till you find the error handler, right? So it never actually returns. Control never returns to the call site for that function. It just unwinds the stack and it's done. So that's what the nothing keyword there is for. Yes? Yes. Mm-hmm. Yeah, map will actually, that I should probably pick a different name because it gets confusing. But that property that I defined, map, that's a mutable map, it's an actual field on the example class. So if you look at the bytecode, you'll see a class, there'll be a field in the bytecode called map of type mutable map, and that exists there. Now the delegation code, I think, the Kotlin compiler is a little different than Java-C. I think it'll probably generate those methods to do the delegation. It'll probably generate all the methods on mutable map and just happen to delegate into map. And then when you override it, of course, it will use your method to do whatever. But it's all handled transparently for you, which is amazing. All right, it's 11:02. Any other questions? Was this useful? Was it helpful? Are you as excited as I am? I don't know where my spoon is, but I'll find it. So anyways, thanks.